way. Okay, let's look at this. So we have the polygon. All right, so we need a XZ. Does everyone understand why we need an XZ? Why do we need an XZ? Someone tell me. Yeah, so we're working in the front. So XZ. So we need this hexagon or polygon to show up here. So let's say size. So size is going to be tricky because it's going to try to make it. It's based on a circumference, so we'll have to scale it, non-uniform scale it. And again, there's probably like 20 ways of doing this, but let's just go with this. So let's go with the number slider. You have the units set up to what? Do you remember? Looks like you have it set up to inches. Uh-oh. Whoa. Yeah, you have it at 10. That's fine. Inches is fine. Just I need to go. So this value is in inches then. So we have to increase that. So okay. So let's start. So we probably want to get the width right. So
you brought it in, she scaled it?
well, I'm just getting the width right now. So the width looks like it's around 21 feet on just sort of this part. So the thickness of this is about, say, 1 foot, so we'll do 21.5 feet. So if you want to work, so we can put feet in, so I can get a division. Or multiply, or sorry, multiply. So I can put this to 21.5, and I can set B to 12, and then plug that into there. And that's radius, so we need to divide it by 2. So I do a division. So we need to set B to 2. Does that make sense, guys? So this way I'm dealing with the dimension of the width. Module. Middle to middle. Center to center. So like center to center here we're saying 21. Now the next thing is we got to deal maybe with the height. Now by default we know the height is also 21 because it's symmetrical. So we're going to do a scale. And we'll do a non-uniform scale, NU. And this will be base plane, and then we have a scale factor which we want in the Z. Okay? So in this case, we can deal with another division, and it might be about proportions. So the proportions might be like we want half the size, a quarter the size. Let's say 3, and that's in the Z. So yeah, that's making a big number. Let me think, because our output now is still it's a scale factor. So then we got to divide it again. And let's think this through. This is the dimension is 1/3 of that. So we need to take 21. So if we're 21.5 wide and we want to be 7.1 high, actually, right? So we need one. Let's do the. Let me just pause. Okay, you guys gotta pull out your second grade math, okay? Maybe not anymore. Maybe this is high school math nowadays. Okay, so let's look at this. So the next thing now is the rotation part, right? So this is the trickier part, but we're going to use a bounding box.
Because they are like bended, yes?
Yeah, they're like not bended, they're rotated. Yeah. So if I want to rotate this, what am I rotating about? What axis? X. Rotating about X. So we need to make a YZ plane, okay? Does everyone understand that? To rotate about the X. And we're going to do a rotate. I always do a rotate 3D because I want to rotate about the center because I have this plane. And then I want to rotate about that axis, okay? So we can see now it's rotating. And then I want to put a rad. Just like calling out stuff. That sounds cool. That's rad. That's a rad. And we can rotate it now from 0 to some type of angle. Okay? So let's turn off this. Okay, what's next? What would you guys do next? What would you guys do next? This is a tricky one. But we'll. No, you should not switch. This is not. It's a tricky one, but not any more or less tricky. Sorry, I need to open that again. Come on, guys. Use your brains. What do I got to do next? I'm looking at this section for a reason. What's happening to this section?
It's going in, yeah. It's got to go in at an angle, isn't it?
It's got to go, yeah, so we need a thickness here, right? So there has to be an offset. But what's going down here? Do we see the bottom one? Like if we extrude, if this is our shape, I assume, right? So it looks like one story is 2 of these, from what I can tell. This shape is going here. Is there a shape back here that's also going? No. So we really, in the end, just need one top shape. Does that make sense? So we need to somehow split it, right? And offset it, right? And then make a whole new drum. So the first thing we're going to do is an offset. Sorry. Okay. So we can do an offset. And we can say a distance. So that's in inches. So let's say it's 6 for now. Okay. And now we really just need the top part. So I have this geometry, I have that geometry, right? So I could do an explode, and this will break these up into individual segments. Okay? And then I can isolate if I look at my sets, I can isolate or split a list. Okay? And don't forget, this is a list of data. So these are my segments. And it's 0 through 5. Now let's see, split might not work, but let's try. So if I put this in here, I want to split it. I don't know what these segments are. Like if this is 0, 0, 1, 2. So let's get a list item. If I get a number slider, set this to integer, set this to 5, if I pick that, you can see this is actually 0. So 0, 1, 2. So I need 0, 1, 2. So I'm going to try to split this at 2. So let's turn this off. Let's turn these all off. And I'm just going to quickly, just so I can see these, I'm going to grab a line container. So I need to actually split it at 3. So you see now I just have the top lines here. Yes? So now I'm going to do the same thing for the other one. I have to flatten that there. Okay. The reason why I have to flatten it, the data was not coming out as just sort of stored like 0 through 5. It was putting it in, you know, in a tree. So it was branching the data. So now I have these 2 lines, right? What can I do with those 2 lines? We can make, well, we probably want to make a loft, so we can do a loft first. That's one thing we can do. There's also a boundary surface where I can give the boundaries, and maybe it makes it. No, it wants all of them. Let's just try it. Loft is the easiest, where I'll just take 2 lines and loft them. So holding down the shift key, I plug that in, and you see it's having some problems with that. Because the way it's reading the lines. So we can do a join command. Because we exploded them. Oh, and it still doesn't like it. Alright, why is not like that? Okay, it doesn't like it. That's fine. So we don't even have, so we'll just keep the join, but what we're going to do now, we don't want form point. We should be able to do it through surface edge. So surface edge did it. Okay. So there's our surface. Now we can do an extrude. Now this is the tricky part. We need to extrude in a direction that is rotated. Right? You need to extrude at that correct angle. How would you do that? But how I don't want to figure out. We know what the angle is. We have an angle. But say I don't even want to deal with an angle. What can I do? I have this surface, right? I have the rotation. Right, I have that. So I do have the angle. Couple things I can do. I could just put a plane here that's running, in this case, xz, and then rotate it with it. And then I know I want to move it in that direction. So then I can put that plane as the direction. So let's try that. And then, so direction is working through a vector. So a vector needs, what does it need? Position, start, direction, and magnitude. So this D is looking for that. So we could plug in a line, an SDL line. Okay? So but first let's make the plane. Does everyone understand what I mean by we need to make a plane for X, Z? Okay? The reason why I want a plane because I want to rotate it now. 3D rotate it the same radians about the same center. I'm going to turn all these other ones so we see it off. And I want to rotate it about, in this case, the YZ, and we have a YZ. I'm just going to delete all this right now. Okay, so see now it's rotating the right way. So now what we can do is make an SDL. We can also do it with a vector. Let's do it with a vector. But a 2-point. Let me see. Let's try it with an SDL. So this is start. So that's the start. Our direction is also at the start. And then our length. Let's see if this works. So in this case, it went 3 inches in the negative. You see that? So if we plug that in here, it's going to extrude at 3 inches. So it's easier just to use a line for the... And say we want more, this needs to be... be able to go to 12. Okay. So far so good. So now if we rotate this thing, it's going to rotate. Okay. Now we got to get this stacking. So the first thing, if we look at the image, this has to go to there. So that's easy. So we just need to figure out what distance we need to go from there to there. So what is the separation? So the entire module, in theory, is not in theory, but in the actual, is the entire sort of hexagon, right? So what we can do is we have that hexagon, right? We started out with this hexagon, right? And then we scaled it and so forth. So we want the one that we came to here, we rotate it. So there's the whole hexagon. So what we're going to do on that hexagon, we're going to get a bounding box. And the bounding box is going to be made for the whole object. So we get a sort of distance from there, and then we're going to be able to get the height of that. box. Okay. So when this comes out, we get a one box aligned, and then this is also orientated to the plane. That's fine. So we need the height of this. I'm trying to think the best way to evaluate. We can do a distance, but I don't think we can do it like we can't. We might be able to deconstruct the box. Let's see. Maybe not. So we can get a B-rep edge. There is there's dimensions. It's in the U and the V. That might work. No, it doesn't like that. I think it's only just for a surface. Volume, moment. So let's just go with B-rep edges. And then we need one edge, right, for the height. So we can get a list item. So right now that's the bottom edge. We don't want the bottom edge. We want the vertical edge. Oh. Okay, so we need that. So now we're going to get a distance. Or we can get a length. Sorry, we're going to get a length. So this is how tall. So this is going to be our array offset. Does that make sense so far, guys? A little bit? So let's look at what options we have for array. Now there is a linear array, and this is like, what do you want array? The linear array direction, and then the number. Okay. So we want to array this. Direction is going to be what? Z, right? And we also need to give the size. So the size is going to be that length. And then we need a count. So let's just do 2 for now. Okay? So far so good? So let's look at, so now we have this bottom one. We still sort of have, I mean, we theoretically don't have, like, if we're going this way, this one is hitting there to make the bottom, but there is still like a bottom thickness, right? That's like double thick. You guys see that? So right now, we really just have this thickness, but then it's like a double thick, based on what I'm seeing here. So we still need to do a bottom piece. That's doing, right? That's doing its part. So let's and then extrude this some more. So we have a little, I think it's definitely thicker. Alright, so somehow we have to get a bottom part that sits here, it looks like, huh? Right? Does that make sense? So somehow this has to get mirrored. So let's look at mirror commands. What mirror commands we have. So mirror, and it's about a plane. So if we want to mirror about a plane, it would have to sit right here. Or on the outside face, which we might have, right? We actually have the inside, so we might be able to extrude it negative. I don't know if you guys are following this at all, but so I'm going to extrude this negative. Like that. Okay. So now we should have the outside plane that we rotated with. Hold on. So I should be looking for an XZ, which is that. Let me just turn everything else off. Alright, so that's that plane. And now we want to mirror all of that. We're not able to mirror it all at once. Okay, so let's do one at a time. Let's try to mirror the extrusion first. Okay, so it's not quite mirroring. It's mirroring it, but we want to mirror it. We want this to be actually laying flat. So we need XZ. So we're going to do another rotate on it. And change the rotation here. We're going to disconnect this. I'm going to switch 2 pi That wouldn't be 2 pi. What is not even 1 pi. No, it's not even doing it. So you know what? This not even do. Let's just do rotation. The mirror's not a mirror was a bad idea. So this actually just do. Let's just take the extrusion and let's just rotate it. Okay. I think that's what we want. And let's just let's get a rad. And let's put 180 in here, just to make sure it's 180. Okay. Now if we plug this in there with that, so now we see the issue. Like, I assume these are supposed to line up, right? So this is like we're drawing it. Like I tell you guys, you need to draw this stuff in Rhino to figure it out. We just took the height of the box. That, you know, we're using the height of the box to sort of do it. That's obviously not working. So let's look at so somehow this should probably be lining up with that. And then the extrusion has to happen correctly. So we did the so it needs to either get taller, right? So before we were dealing with just the length, which in this case this is completely useless. And let's go ahead and put a number slider in here. So basically, we have to figure out, this is where some mathematics comes in. Because based on the angle of rotation, it's going to change the height, and it's going to change then the extrusion. Because our extrusion needs to even be bigger now. So that they meet. You guys getting this? Yeah? And this should all be somehow rigged to us just changing the size of the polygon and changing the rotation angle. So as we change the rotation angle, everything sort of adjusts properly with the width of this and the height of this. So there's a lot of sort of mathematical connections that are happening. And if we increase now, and this will work as we go up, right? And then the question to get it going the other way, it would be, it's the same, it's sort of the width, probably module to module, but then it's an offset of half of what the height is, right? So it's moving it to the right and then up half.
Professor, so we cannot do something like that we could align these points like from one shape, align this point with this point, align this point with this.
In this case, it's not aligning. It's more for this specific one. There's mathematics involved here, and I'm not even doing a good job here, sort of faking it. And you can see there's even weird, like dealing with how to deal with the top and bottom being different. Even gets more complex. And I'm not sure. It's hard to tell. I mean, this is what you guys have to research, Like, what are the alignments? Like, there's some, when you have a shape like this that's tiling, there must be something happening very unique at this situation, because for this to sort of, does this go past? It looks like it's folding at the right spot. So how it sort of tiles up here, this inside shape, this must not be at the same angle that we think it is to make this happen. So starting with the with the hexagon might not be the best. It might be just drawing the profile and understanding the angle or something there, right? So there's geometries here, right? There's a whole sort of underlying what's the word I'm looking for? Sort of patterning that's happening, that's dealing with also with thickness. So that's why I was telling you guys, draw these things 2D, and I think if you draw them 2D, they'll reveal themselves. And then you go into Grasshopper and you go, okay, I know how this thing really works now. I'm an expert on this facade. I can try to figure out what the parameters are and how to make them work. So then we get a little bit closer, because you can see like somehow this doesn't line up. And the reason why it doesn't line up, because we have this bottom part and this upper part. These lines probably don't want to just go this way. They have to, there has to be some type of offset that's not happening equal or something, right? Because it's getting a thickness this way and a thickness that way, and then when you try to line them up, they're not lining up. They line up in the middle because that's where the shapes are, but they're not lining up. So maybe it's an offset from the middle, offset this way and offset that way, and then make the, does that make sense? But until you draw it, and you know, it's hard to say. Because right now, it's like they're lining up in the center point, but we need them to line up in the bottom and then the top. So somehow halfway here this has to meet, halfway there that has to meet. So this angle isn't quite the right angle. The angle, you know, if we're trying to line, and one, you know, and one's lining up this way, but the other one's lining up that. They're meeting in the middle, but they need to meet there. So this angles are going to be slightly different. But I think when you draw it up, you'll figure it out, like what that is. So like when we're just doing this and offsetting it, it's not giving us. We need potentially, you know, a different shape, a different sort of miter. The miter might not be a 45 or whatever, an equal. And again, get as close as you can. Okay?